video, we're going to look at how we can solve exponential equations simultaneously. Given an example, solve 4 raised to the power 2x plus y equal to 1 over 256 and 2 raised to the power x times 4 raised to the power y equal to 8. Solution. So we can solve these exponential equations simultaneously by first reducing exponential equations to linear equations. How's that done? Then let us look here. Writing the first equation, exponential equation, 4 raised to the power 2x plus y equal to 1 all over 256. This could be written as 4 raised to the power 2x plus y equal to 1 all over 4 raised to the power 4. You know, 4 raised to the power 4 means you multiplying 4 by itself 4 times, and that's going to give you 256, right? Yeah. So this could be again written as 4 raised to the power 2x plus y equal to 4 raised to the power minus 4. According to indices, a raised to the power 1 all over a raised to the power m could be written as a raised to the power minus m. Okay, so because of that, we can write the 1 all over 4 raised to the power 4 as 4 raised to the power minus 4. When the exponential equations are having same denominator, then we can equate the exponents. So looking at these, we can say that the bases are the same. Since we have 4 here and 4 here, then our exponents 2x plus y is going to be equal to -4. That's going to be our equation 1, right? Then equation 2, to get equation 2, we're going to solve this. We're going to try to change the 2 raised to the power x times 4y, 4 raised to the power y equal to 8 into linear equation. So this could be rewritten as 2 raised to the power x times 2 raised to the power 2y equal to 2 raised to the power 3, right? So you know, 2 raised to the power 3 means 2 times 2 times 2. That's going to give you what? 8. So in place of the 2, in place of the 8, we write 2 raised to the power 3. And then a 4, 2 raised to the power 2 is equal to 2 times 2. That's going to give us 4, right? So in place of the 4, that's why we have the 2 raised to the power 2. Then the y, you know, the y is multiplied by the exponent of the 2, right? So we have 2y. According to indices again, if you have a raised to the power m times a raised to the power n, this could be written as a raised to the power m plus n. When the bases are the same and the operation between them is multiplication, then you can add the exponents. Here our bases are the same, and therefore you can add the exponents of the exponential equations. So we have x plus 2y. So we have added it, and then this should be equal to 2 raised to the power 3. Now that we have it in this format, we can also verify that the bases of both sides of the equation are the same, which is 2. And since they are the same, we can equate the exponents. So we can say that x plus 2y is equal to 3, and this is going to be our equation 2. So looking at this, we have reduced the exponential equations to what? Linear equations, and we're going to solve these simultaneously. In solving them, we can use elimination method or substitution method. You can also mix them. We're going to mix them, but first let's look at the elimination method. We want to eliminate one of the variables, but the coefficients of all the variables are unequal, hence you have to try to let one of the variables have equal coefficients. I want to eliminate x, and the coefficient of this x is 2, this one is 1. I'm going to multiply 2 by equation 2, right? So that the coefficient of my x's are going to be equal. And 2 times x is going to give me 2x. 2 times 2y is going to give me 4y. And 2 times 3 is going to give me 6. And we can say, let us make this equation 3, right? Then we can now subtract equation 1 from equation 3. So 2x, we say equation 3 minus equation 1, okay? So we have 2x plus 4y equal to 6. Then 2x, that's equation 1, 2x plus y equal to minus 4. Then we're going to subtract the whole of this from equation 3. In doing so, 6 minus 4, 6 minus negative 4, negative becomes positive, so it is going to be 6 plus 4, and that's going to give us 10. So 6 minus negative 4 is going to give us 10, then equal to 4y minus y is going to give us 3y. 2x minus 2x is going to give us 0, right? Looking for y, but we have 3y is equal to 10. So what do? We're going to divide both sides by the coefficient of y, right? And then our y will now be equal to 10 all over 3. Okay, so having gotten the value for y, we can do some substitution here. Going to substitute the value for y into any of the equations to get the value of x. Let us put y is equal to, what did we get for y? 10 over 3 into equation 2, right? Let's put it into this equation. Equation 2 is giving us x plus 2y equal to 3. So in place of y, you're going to be substituting y for 10 over 3. So we have x plus 2. Then in place of y, we write 10 over 3 equal to 3, right? Now x plus 2 times 10 is going to give us 20 over 3 equal to 3. We're looking for x, so we have to send this across the equality sign so that the x will stand alone, but it is positive. When you cross, it becomes minus 20 over 3. So solving this, you're going to find the LCM of 3 minus 20 over 3. This 3 is over 1, so our LCM is going to be 3. 1 goes into 3 how many times? 3, right? So you multiply that 3 by 3. Then 3 goes into 3 how many times? 1. So you multiply that 1 by 20. So our x is going to be 9 minus 20 all over 3. And from this, our x is going to be equal to negative 11 all over 3. Therefore, our x is equal to minus 11 over 3, and our y is equal to 10 all over 3. Yeah, If you find this video interesting, you subscribe to the channel for more of such.